Alright, here we are. This is the rest of the review. So in this problem, we are starting with a cube, and as far as volume goes, for volume we're taking away the volume of the cone, but as far as surface area goes, we're kind of adding the surface area of the cone. So let's look at the surface area of this. Let's start with if it was just a regular cube. Now the surface area of a cube is really easy. You just find the area of one of the surfaces, which is 7.84. So each surface is 7.84. How many surfaces are there on a cube? There's 6. So I'll multiply that by 6, 47.04. So that's the surface area of this cube. Alright. But to get this, what we need to do is we need to cut out a circle from the top of the cube. So we need to cut out a pi r squared. The radius would be 1.4 if that's 2.8. So pi times 1.4 squared is, we need to cut out about 6.2. So we need to take away 6.2. We start with that, then we got to take away 6.2 for the top of the circle, and then we have to add in the cone, but just this part of the cone. We don't want to add the circle back because we just took that out. We want the lateral area. We want the lateral area of this cone, which is pi RL. So pi times 1.4 times, we got to figure out what the slant height is. Alright, well, we're going to go in here. We have to make a right triangle to figure out what that slant height is right there. Alright, well, easy enough. 2.8 squared plus 1.4 squared. Do the square root of that, and you get 3.1. Alright, so the slant height of the cone is 3.1. Little field trip, which gives us a pi times 1.4 plus 3.1, 7.5. Alright, so 7.5. Alright, so put it all together. We start with the cube. We take away a circle from the top, so we start with 47. We take away 6, but then we get to add all of this surface area here, which is 7.5. So to figure this out, to end with, I'm having a hard time with my paper, 47.04 minus the circle plus the cone. About 48. So we went from surface area total is 48.3. Which is a little bit more. So by putting the cone in, yes, we had to subtract some, but we added more than we subtracted. So we actually increased the surface area. Now volume is going to be quite a bit easier. Volume, you just take a cube minus a cone. Cube minus a cone for volume. So for this is going to make the volume go down because we're taking away the volume of the cone. So the cube is really easy. It's length times width times height, or 2.8 cubed, thus the word cube. And then minus a cone, 1/3 pi r squared h. You can plug in from there. You've got the radius, you've got the height. I think you can take it from there. Alright, now on to the next page. In this scenario, we are given the volume and we have to solve for the radius. This could very well be a test question. This is not a hard problem. So the volume of a cylinder is pi r squared h. That's base times height. Base times height. Base is a circle, so pi r squared times height. So we can plug in the volume. We're actually going to plug into this side of the equation for the v. And the radius is unknown, and the height is 9. So now what I'm going to do is do a little calculator magic here. I'm going to start with this in my calculator. I'm going to divide the pi. I'm going to divide the 9. Alright, so I divide the pi and divide the 9 and I get 9. So 9 is equal to r squared. That makes it easy. Square root of 9 is 3 meters. That would be 3 meters when we finish that problem. So that was not a hard problem. Number 6. A pyramid with a square base. Alright, let's stop and draw a pyramid. So there's our pyramid. And it's got a square base. Has a volume of 320. So right there I'm going to be using the volume of a pyramid. Alright, there we have it all set up. Volume of 320 and a height of 15. Look at that, we even got our height. Find the side length of this square. Well, what we can do is we can find the area of the square. Let's just keep that as b. Alright, now to do a little calculator magic here. We'll start with 320 in the calculator. We'll multiply by 2 to get rid of that 1/2. And we'll divide by 15 to get rid of that 15. Which gives us a, seems odd, height of 15. It's a weird number, but there you go. Oh, I did a half here. Silly. That should be a third. Why do my thirds always turn into halves? That happens. Let's rerun this. 320 times by 3 divided by 15. That's better. That means the base is 64. The area of the base, the area of this square is 64. What type of square has an area of 64? It'd be an 8 by 8 square. 8 is the answer, centimeters. Because 8 times 8 is 64. Area of the base is 64. Number 7. The volume of a cylinder is 64 pi. Okay. Volume of a cylinder is pi r squared h. 64 pi, we can plug that in. There we have it. The volume is 64 pi. I'm going to solve for this. The radius is equal to the height. Interesting. Radius is equal to height. So what I can do here is, what can I switch the height for? For another radius. Like that. So I got radius and radius. Height is radius. Radius is equal to height. So if height is equal to radius, then I can go ahead and change that h to an r. And we can cancel these pi's out. What's r squared times r? How many r's do we got? We got r times r times r times r. That's r cubed. Which means what cube gives you 64? Is it 2 times 2 times 2? Is it 3 times 3 times 3? Is it 4 times 4 times 4? It is. So 4. Radius is 4. But what were they asking for? They're asking for the surface area. So we have to go back and now run surface area of a prism. That would be 2 pi r squared plus 2 pi r h. All of these formulas are on your formula packet that we went through, and I'll give these to you before we take the test. So the radius was 4, and the height was also 4 because it's equal to what it says. We can do this pretty. That's 16 times 2. That's 32 pi there. That's 16 times 2. That's 32 pi there for a total of 64 pi for the surface area. 64 pi is 201. Units squared, since they don't give us the units, surface area is always in units squared. So let's recap the problem. We had to use the volume to find the radius. Turns out the height was the radius. We used the radius to figure out the surface area. Number 8. A square pyramid has a slant height as 1. Okay, well, let's just draw our square pyramid to start off with. So there's our square pyramid. Slant height that is 1 unit longer than its altitude. So here's what that means. It means if we draw this altitude here going from the top down to the bottom, we do the slant height going down the side, here's what this triangle looks like. If this is x, let's say the height is x, the slant height is 1 unit longer. Like that. That's what we have. We also have the perimeter of the base is 40. So what type of square would have a perimeter of 40? That would be a 10, 10, 10, 10. 10 plus 10 plus 10 plus 10 is 40, which makes this length half of 10, which makes this 5. Woo! Find the surface area of the pyramid. Alright, well, let's do surface area of a pyramid. Surface area of a pyramid is 1 base plus 1/2 LP. That's the formula for surface area of a pyramid. The base is easy. It's a 10 by 10 square base, so it's 100. 10 by 10 would have an area of 100. Do we know the slant height? No, we don't. Do we know the perimeter? Yes, we do. Perimeter is 40. So we need to go in here and do some algebra to figure out what x is. And that's going to take a minute. That's going to take a minute to do some algebra. What do we know? We got the Pythagorean theorem. We got x squared plus 5 squared is equal to x plus 1 squared. I'm just going to say, if you do the algebra, you're going to get that x is equal to 12. Do that algebra. You have to FOIL this out, which means x plus 1 times x plus 1, which means you have to double distribute. I'm just going to give you a spoiler. It's 12. Foiling will not be on your test. So this ends up being 12, which makes this 13, which makes that 13. So plug that into your calculator, and that's what you get as your surface area. So 100 plus 0.5 times 13 times 40. 360. Units squared, since it is area. Alright, so that was a tough problem. Like I said, these are hard problems. This is everything. This is surface area. It's foiling, going back to algebra. It's using area, perimeter, slant height versus height. This is a tough problem. Last problem. Find the volume and surface area of a hemisphere with a great circle of 25. This is not a hard problem. Here is our hemisphere. Alright. It's half of a sphere. The great circle is this circle right here. It's like the equator. And it's saying that the circumference is 20 pi. The formula for circumference is 2 pi r. So we can go ahead and cancel those pi's off, divide the 2, and you get that the radius is 10. Alright, now the rest of this problem is just plugging in. The volume is 2/3 pi r cubed. That's the volume of a hemisphere. Again, you'll get these formulas. You just have to know how to use them. 2/3 pi times 10 cubed. We can go ahead and plug that in. 2/3 pi times 10 cubed. About 2094 inches cubed for that, and surface area ends up being 3 pi r squared for surface area. So this ends up being 3 pi times 10 squared. 942. 142.5. Square units for area, cubic units for volume. Alright, that's it. This, like I said, these were some really tough problems. Your test won't be like this. You will have to do some hemisphere stuff. You will have to do problems like this, where I give you the volume and you got to solve for one of the lengths. You will have pyramids. You will have cylinders. You will do surface area. You will do volume. Alright. You will have prisms like this where the height is not necessarily obvious. You will have composites. Alright. Good luck. Hopefully you watch this video and it's helpful for you. Please email me if you'd like to chat.